In Try This 4.9.1, we're going to be using Newton's method. And Newton's method is not hard, it's just an iterative process. But sometimes when we have these iterative processes, we forget what the numbers that we're finding represent. So I want you to take a moment to think about what x sub 3 represents. All right, let's take a look at this first example, and we'll remind ourselves x sub n plus 1 is equal to x sub n minus f of x sub n all over f prime of x sub n. And so we're going to need the derivative. We're going to need f prime, right? So let's go ahead and do that. So we have y prime, that's the same thing as f prime, right? Just different notation. Y prime equals 3x squared minus 3. And in this problem, I'm giving you an initial guess of x equals -2. So here's my x naught. And why am I giving you that initial guess? Well, if you were to just look at this equation and you were to make an initial guess, let's say you guessed that it crossed at x equals 1.5. Okay, so if you had made this your initial guess, and you look at the tangent line at that point, you can see that it crosses at about 0.5, and then that would be our second guess, and then what we would do is draw a tangent line at that point, and it would cross over here, and that would be our third guess, and then we would draw a tangent line at that point. And do you see how it keeps alternating back and forth? So that actually is one of the problems that we described when we talked about the times when Newton's method goes wrong. All right, so I want to avoid that. So I'm giving you an initial guess of x naught equals -2. Okay, so let's get started with our calculations. We know that x naught is equal to -2. So x sub 1 is going to be equal to x naught minus f of x naught all over f prime of x naught. And in this case, x naught is -2 minus f of x naught means plug x naught into your original function, right? And so we plug -2 into our original function. And if we do that, we get -2 cubed is going to be -8. And then -3 times -2 is going to be +6. So that's -8 plus 6 is -2. And then we're adding 5 is going to give us 3. And that's all over f prime of x naught. And so in this case, we're plugging in our value here. So if I plug -2 in up here, I'm going to get 3 times -2 squared, and that's going to give me 3 times 4, which is 12, and then I subtract 3 from that, and I'm going to get 9. So let's do the calculation. And I get -2.33 repeating. So I want to make sense of this number before we go any further, because a lot of times people start calculating and they don't know what they're finding, and so they get the wrong answer. I actually caught myself in an error when I did this earlier. I came up with a value that was like +2, and I realized that I had plugged in, instead of using x naught equals -2, I had used x naught equals +2. And so I found myself in an error. So if you know what this represents, it actually helps you to make sure that you're not going astray. All right, so our initial value is x naught. Remember, what we're trying to do is we draw a tangent line at that point, right? And we find out where that tangent line crosses the x-axis. It's a terrible line. But it crosses somewhere in here. And I got the value -2.33. So that looks about right, doesn't it? Okay, so that's my x1. Now we can find x2 from there. And so you can just go ahead and do negative x2, remember, is x1 minus f of x1 all over f prime of x1. And this is actually great. This is a great place if you can use, if you can input an equation into your calculator and then plug in different x values, that's great. You can also use the Desmos calculator and plug in an equation and then plug in your different x values. And I'm going to go ahead and do that so that it's more time efficient. So I've done that on the Desmos calculator, and I get that x2 is going to be -2.2895, so on. And then we're going to use that to calculate x3. And as you can see from the table, x3 is going to be negative 2.2790201. And we could go on, right? And you can see from this table over here that if we calculated x sub 4, that would be fairly darn close to the value that we currently have. So eventually it's going to approach some number, isn't it? All right, so let's take a look at where the graph actually crosses. The graph actually crosses right here. And so it looks like a pretty good approximation, doesn't it?